Hello, this is Tim Smith, the Academic Support Coordinator for St. John's River State College, St. Augustine campus. This video on inequalities is designed as a study aid and supplement to the math tutoring services offered at St. John's River State College. In mathematics, an inequality is a relation which makes a non-equal comparison between two numbers or other mathematical expressions. We can consider the simplest of examples, 5 is greater than 3, writing it mathematically as 5 and 3 separated by the greater than sign. The chart depicted here describes each of the signs used to describe an inequality: less than, greater than, less than or equal to, greater than or equal to, and not equal to. As a means of remembering, notice that the symbol always opens up to the larger number, and the underlined symbol indicates that in addition to greater than or less than, the value is also equal to. Examples for each are given. An inequality can be graphed on a one-dimensional line that extends from negative infinity to positive infinity. In this case, the graph is centered on 0, but that is not a requirement. If we wanted to graph the inequality x is greater than 2, we first realize that the depiction must show correct answers for x, in this case, anything to the right of 2. Note that we use an open circle to depict greater than, but not equal to. Likewise, if we were to graph y is less than or equal to negative 3, then we would start at a negative 3, include any number that is to the left on the number line. Note that we use a closed circle to indicate less than or equal to. A linear inequality in one variable can be written in the form ax plus b is less than c, where a, b, and c are real numbers and a is not equal to 0. Solving inequalities is similar to solving standard equations. In most cases, an inequality sign will behave similarly to an equal sign. Starting with the inequality 2x plus 5 is less than 9, we can proceed as if we are solving the equality. We can subtract the 5 from both sides. This leaves 2x is less than 4. Then we can divide both sides by 2, leaving the final solution, x is less than 2. The property of additive inverse states that for any real numbers a and b, if a is greater than or equal to b, then negative a is less than or equal to negative b. And if a is greater than b, then negative a is less than negative b. This property tells us that any time you multiply or divide both sides of an inequality by a negative number, the signs must be reversed. We will demonstrate with the example negative 3x minus 7 is less than or equal to 8. We start solving this problem by adding 7 to both sides, leaving negative 3x is less than or equal to 15. This time, to leave x alone on the left side of the equation, we must divide by a negative 3. When we reverse the signs, we are left with a solution x is greater than or equal to negative 5. Suppose that a and b are real numbers and a is less than b. The notation a is less than x is less than b means that x is a number between a and b. This expression is equivalent to the two inequalities a is less than x and b is greater than x. Although writing the inequality b is greater than x is greater than a is mathematically identical, it is preferable to write the expression from the smaller value to the greater one. In the example, we have negative 3 is less than x is less than 5. The graph depicts values between negative 3 and 5. Note that both negative 3 and 5 are depicted with open circles as the inequality is less than. Solving a combined inequality is the same as solving a single inequality, remembering that what you do to the center term, you must also do to the two terms on either side of the inequality signs. In this example, we start with 2 is less than or equal to 3x minus 7 is less than or equal to 5. When we add 7 to the center, we must also add it to the 2 and the 5. The same is true for the division operation. we divide the center term by 3 to get x alone, we must divide both sides of the inequality by the same 3. Our final answer is 3 is less than or equal to x is less than or equal to 4. Interval notation is a way of writing subsets of the real number line. If we let a and b represent two real numbers and a is less than b, then an open interval denoted by ab and using parentheses means the interval consists of all real numbers x for which a is less than x is less than b. A closed interval denoted by ab and using the squared brackets means the interval consists of all real numbers x for which a is less than or equal to x is less than or equal to b. The half open, half closed intervals are AB with parentheses indicating open on A and a squared bracket meaning closed on B, means the interval consists of all real numbers x for which A is less than x is less than or equal to B, and AB consisting of all real numbers x for which A is less than or equal to x is less than B. It is common in mathematics to have answers that are required to be expressed in interval notation. The graphic here displays a number of inequality combinations with their interval notation values. On a one-dimensional graph, the interval notation parentheses and brackets are more often used than the empty and filled circles discussed earlier. Note that whenever infinity is used, it is expressed as an open interval. A linear inequality with two variables will look similar to a linear equation and can be written in standard form or in slope-intercept form. Note the standard form ax plus by is greater than c. In this form, a, b, and c represent integers. And the slope-intercept form, y is less than or equal to mx plus b, where m is the slope and b is the y-intercept, and both are rational numbers. The slope-intercept form of the linear inequality is usually considered the easiest to graph, as the slope and y-intercept may be easily identified and plotted. One side of the line is then shaded to depict all combinations of x and y coordinates that create a true inequality. To graph, create the line using the y-intercept and slope. If the inequality is greater than or less than, use a dashed line. If it is greater than or equal to or less than or equal to, use a solid line. Shade the appropriate side of the line. When in doubt, use the point 0, 0 to verify. Enter 0 for both x and y and determine if the result is a true statement. If true, then shade the side of the graph that includes the point 0, 0. If false, then shade the opposite side. When two inequalities are together in the same problem, we call it a system of inequalities. These two inequalities will be separated by a conjunction, either and or. A graph is the only way to accurately depict the solution to a system of inequalities. Graph them both, remembering to use a dashed or solid line as appropriate, and shade the correct side. If the conjunction or is used, then all three shaded segments will depict the correct answers. If the conjunction and is used, then only the segment shaded by both contains correct solutions. If you have further questions on this or any other math topic, or wish in-person tutoring, please consult the Academic Support Coordinator on your respective campus. Thank you, and good luck with your studies.